And we're live. Welcome, everybody. I'm Billy Jitsu, Community Manager and Hackathon Lead for Developer DAO. I'm here with Joshua at Phala Network. You should know who this is already. Let's say what's up, Josh.
Howdy. How's everybody doing?
All right. So we're going to take you into the next workshop, the next iteration to prepare you for Hackathon Part 2. For those that don't know, we just had our first Lens API Hackathon with Phala Hackathon, right? And so we learned how to use, the FAT contracts, how to call a Lens API specifically, and then use that in a smart contract level, and then do something cool with it. Now we're coming out with the new blueprint, right? Josh, is that the right term, blueprint?
I would say just for this one, it'll be more of like a feature of FAT contracts. So we'll call, in this case, we call this the FAT functions. So the FAT functions are like a key piece of the blueprint architecture. But yes, this is something that helps us, like I guess, like how I'd say this, like underlying of the Lens API Oracle that we deployed last week. This is how we're able to do this. So I'll show you kind of like an update of how that looks with the new updated Lens API consumer template as well.
Got it. So in our last hackathon, it was pretty much limited to the set of Lens APIs. And now we're opening the doors to like a whole new world of what is capable of happening. And on that note, I'm going to go ahead and pass it over to Joshua and take over.
Awesome. Yeah. All right. Well, hello, everybody. I'll start off with taking this little gist here. If I can, I think I have to join the chat. Let's see, connect to comment. Oh, okay. Let me put in the private chat then. So this is kind of the gist here under my GitHub of all the resources that we'll kind of go over today. The first one that I will start off with is the Lens API Oracle consumer contract template that we've updated. So we can go here. Actually, I'll keep this tab open.
Can we make that screen just a little bit larger to be viewed?
How's that look?
Looks good. Much better. Yeah.
All right, sounds good. So like we did in the last hackathon and last workshop, we had this template called the Lens API Oracle consumer contract. So what we've done is we've updated this to enable you to run a few more commands, but also be able to integrate the FAT functions into this locally, so that you can locally test against this. So in this case, that file that you will be editing will be under this source folder, and then this file here, index.ts, this will be the file that you would edit to be able to create your functions. So this entire file would be something valid for you to build with your FAT functions whenever the FatBricks UI is ready. So you'd be able to update something similar to this and create a file that would be able to do a transform on the information that's being returned based on a request that you have from your consumer contract. So what I'm going to do is kind of show you like a little demo of how this works, and then how the test will operate as well. So I'll open up my my IDE here. Let me find it.
So while you're opening that up, just to recap, this is just looking at it really quick. This is kind of like the Lens API call. You're doing it instead of doing it on the front end wizard. You're kind of just doing it through the IDE, right?
Yes, exactly. And then we've also added some extra functionality so that you can test this locally as well. So you don't have to do a full deploy. You can run it locally on Hard Hat and then run some tests against it, so you can see what the expected output would look like, and see how your function would transform on the data that you have being passed in.
Got it.
So I have it here. Bring it over. So for instance, can you see my screen?
Yeah, if you can make it a little bit larger, you read my mind on that one.
Yeah, I'll have to. I think I need to figure out how the view works on this. I forget.
I'm a Windows user, so like usually it's Control plus, so maybe Command plus.
Oh yeah, it's like the IDE zoom is a little different. There we go.
Okay,
that's pretty.
it's good. That's good.
Okay.
If you can't see it in the audience, just go ahead and shout out. But I think that I can see it. So so far so good.
It's a little. Okay, I think that's better. So I can. There we go. Cool. All right. So just to kind of go over this file. So this is what was happening on the back end of your Lens API Oracle. So what we had, just like our test Lens Oracle file, which is actually this file here. So it's the test Lens API consumer contract. I need to update that. But these are like your type responses. So if we open this up here, it's correlating directly to this, like your type response, your type error. And then we also have our errors here with the bad lens profile ID, the failed fetch data, failed to code, and the malform requests, which I believe will be returned whenever we hit these errors. So like you'll have these errors that get returned whenever we have an error received. And then this data here would be able to emit that error response in this case. So yeah, error to the code. So we have some functions here for correlating the number to the error code. We have a check as well to check that whenever you submit a request. So whenever we were here in the request piece here, whenever we had that profile ID passed in, we now have like a check to see if it's a hex string, see if it begins with 0x, and then a valid hex string format here. We also have this function here, which is string to hex, which whenever we have a body, so say that we're doing a query, so we want to query the Lens API. So we have the query profile. So this is the syntax that you would use for like GraphQL through like I believe the endpoint is Mumbai dash Lens API. Let me see if I can find that in here. Ooh, oh, we passed it in. Okay, so I'll find that here in a second. But anyways, this would be your query, and then what we would do is then use this string to hex function to create the body string hex representation, so that we can pass it in to this pink.batch HTTP request. So in fat contracts, we have this pink extension, and whenever we implemented our quick.js engine within our P runtime for our fat contracts, we're able to give this command for the fat functions in this case to batch HTTP requests. So not only can you just send this one post request, you can also add other ones within it to make multiple requests. So say that you still wanted to work on something with your last project during the Lens API Oracle Hackathon challenge, you can now extend that functionality to be able to add more queries. So I believe each batch can handle up to 5 HTTP requests. So you can have 5 different queries, and you can get the response data from it, and then also use that response data to do some other custom calls, or maybe like you're posting to Lens API for your Lens profile or something, or etc. you can do a lot more with this like a batch HTTP request. And I'll show an example of multiple requests later. But this is kind of just like the back end of what we saw last week. But now it's available as a function, and then you can do a little bit more opposed to just being limited to these 7 stats now. So this is exactly how it is working in the back end. And then from here, this is some other checks here with the checks for the bad lens profile ID, and then we have our main function here, which will handle this request whenever a request is passed in. So this hex string, which should be a profile ID hex string, and then come down here and we'll do a try. From this here, we'll get a request ID, which the request ID is mapping to, if we go to our contract, it'll be mapping to this ID here that's in our mapping of a request to our strings here. So in this case, like the profile ID. And from there, we'll decode. And if it detects that there's like a malformed request, then we'll report that error and encode the reply and then send this back. If not, then we'll parse the profile ID. We'll get the request, and then we'll fetch Lens API stats. And then in this case, this was getting the stats for the response data of the total requests. We have a response, encode reply. And then we'll send this reply right here, our type response, with the stats that we allocated from the response data from this lens, this fetch lens API stats function that we defined above. So what's really cool about this is now we have a way to test this locally. So I have my local hard hat node running right here. But just to kind of show you what the commands are for this. So the commands will be these 4 right here, if you can see my screen. So whenever you clone or you create a template from the consumer contract repo, you'll run yarn, and then you'll copy over the dot environment. Well, here it's like copy local environment to copy over variables, your local variables, and then you'll update those with the appropriate variables for your local node testnet. Then you'll run this yarn build function. So whenever you're in your repo, so whenever you run that yarn build function, it will then take this, like the latest that you've done on your changes here, and then build that so that you can then start your new local hard hat node, and then run your test against it to see like what the expected test would look like. And from here, you can also like customize your test here with more tests that maybe like for whatever you're building for in this case. So this is the example of the test lens API consumer contract test for the Mocha test here, where we in this case we're testing against a profile 0x01. So just to kind of show this, I can do this yarn hard hat test, maybe add some more. Debug here. So from here, we can see that we were able to run the new like function. So this is also like, if you see here, this @Phala FN. I don't know if this screen's too, or the size is too small, but this is like a new command for our fat functions CLI tool, so that you can create like one of these. You can generate one of these templates or a fat functions template. But I'll show this a little bit later, so I don't get too ahead of myself. But just kind of going through like the test here with like all the debug logs, so that you can view how the tests are running here. I may have like printed off a little bit too many logs, but essentially this is how you would execute your tests and be able to see the functionality locally. And then I'll show you a different way a little bit later with the project that I built. But just to stop here, if there are any questions about kind of this flow, or if it doesn't make sense, or if there's any other questions, like for anybody that may want to expand on anything that they would want to implement with the Lens API Oracle, or expand on for this next like fat functions hackathon.
I have a quick question on that. Like, based on like the user count, right? So you had post count, comment count, follower count. What other options now that you have, the fat functions, can I call or create? Like, any ideas that I would do on that 5-call API?
Oh yeah, so now it's fully open. So you can go to Lens API, the Lens API docs, and you can do you have access to all the queries now. So you can, it doesn't matter like that we have these 7 stats. Now you can get any stat that you want, and you can perform pretty much most of the functions that I'm aware of. Maybe like if you get limited at like uploading any kind of like metadata for like any kind of file, in this case, that might be a limit. You'd have to do a workaround, but I can connect with people afterwards if they want to figure out how to do that. But yeah, no restrictions now. You have the full use of the Lens API at your disposal, and you can even also call other APIs to bring into your Lens API DApp in this case.
And so they would just put that under the stats, right, under the request post.
Yeah, so they would so like say in this example, they would come here with this pink dot batch HTTP request, and let me show example of multiple requests in this case.
And this is on the GIS too, right? Just in case, this example.
Yes, yeah. So I'll be updating this to be able to show y'all how like an example of using the multiple requests. But you can see here where I have this pink dot batch HTTP request here, and I'm making my first one, which is calling the odds HTTP endpoint, which is calling odds the odds API, which gets you all of the different sports books, games of the day in this case, and then those games of the day will come with a game ID. But I'll get this, and then from there, since I'm doing a batch HTTP request, I get my first request. I can get the information here, and then from there, I show that I can make another one by just calling, like in this case, like a pink.http request. So like within this batch HTTP request, you can then also create another HTTP request within this. And from there, you're able to, for this case, I do just like a hello world to a key value database on key value DB. I just created like a free account for that and just did a hello world. And then from there, I take all the information that I got from result 1 from the odds HTTP endpoint, and I call another HTTP request, and I get the body of that, and then update a Telegram group through a Telegram bot in this case, and post it into the Telegram group. And that's what I'll kind of walk through that, and we can kind of interactively go through this as well, because there's some like some different things that you can do, and show you how to make all these multiple requests just to create like some kind of functionality that you would want in your application.
Got it. So it all goes within that object array, basically, and all your requests. Very cool. Very cool. And so, like, testing locally, for those that are kind of coming in a little bit late or don't know about the second hackathon, the hackathon is actually going to be on mainnet. Or, I mean, you can run it on testnet theoretically, right? You could kind of run it on testnet, or is it mainnet only, and then submit on mainnet?
So I would suggest just like for those that didn't participate in the last hackathon, they should at least get comfortable with deploying the Lens API Oracle, test locally, and then deploy to testnet. Once they deploy to testnet, reach out to me personally, show me your contract ID, show me like what you deployed, and then we can get you the airdrop of the Phala tokens and the Matic for you to then deploy on mainnet. Right now, we'll support mainnet deployments on Polygon for the consumer contracts. If you want to go to another EVM-based chain for your Fat Functions project, you can do that, but we won't typically like give you more tokens for a different EVM-based chain. But you can take the Matic that will airdrop to you to convert it to whichever EVM chain that you're going to deploy to in this case.
Very cool.
Okay, let's see. So now that I've shown this basic part of the template that we've worked with last week, now we have another piece. Oh, sorry. Another part, which is the Fat Function CLI tool, and you can find this in the gist that I just had open up here. You would go to the Fat Function CLI tool. So here, and now this is the code repo. So it's pretty easy to get started. You don't have to necessarily clone this repo. You can just run this command. So I'll do this now and just do it live. For my terminal. So in here we have this here npx. Make sure you have npx installed on your machine. But what we're doing here is like we're creating a new project. So I'll take this, and then you have to make sure you include your project name. So let's do this real quick. That's not it. Go npx at phala/fn, which is the CLI tool. I believe it was a init, and we can give it a name. So this we can call it dev DAO example. Just check to see if that's correct syntax. Yeah.
So that command will install it for you, so you don't have to pre-install it beforehand. Got it.
So now we can see here from the templates that for the DevDAO example, we can have our Lens API consumer contract. So we'll download it here. So now we have like an environment with the Lens API Oracle consumer contract in this case. So now I've changed directly into my project. I'll do a yarn install.
And that comes in by default, right? With like a template ready to go with the Lens API?
Yep.
Nice. Okay.
And I can open up in the IDE to view this as well. Let's see, before I do all the building. So let's go ahead and do that. Sample. How does the screen look here?
Seems okay to me, but maybe just one more for a boost.
Cool. All right, so we're here. Okay, so we've now installed our dependencies. The next step will be compiling the JS code. So kind of like what I showed a little bit earlier with the Lens API Oracle template. We go to our repo. So just by running this command, it already generates all this for you. And soon, I believe we'll have another option for fat functions so that you can do something outside of something like a little more blank and able to do something outside of Lens API if you would like. So kind of just like what I just showed, it's the same exact code. It generates this template for you just through the CLI. You have this little post command with the batch HTTP request and your main function here, define your logic. So what I'll do next is follow those steps where I build here. So we'll do the compiling of the JS code. All right, so now this is compiled successfully. So you'll see that it'll generate an index.js file in the dist folder. You can see that here. Now we can test it. So first, you could test it by sending no arguments. So let's see. We'll run a test here. Clear this. So as you can see, handling the request is undefined, malform request received. So in this case, whenever I didn't pass any arguments to the transform function in this case for our fat function, it's gonna automatically detect that it didn't get a lens profile ID, and in this case, it cannot handle this request practically. So now our expected output, as we would be testing locally, would be a malform request, and we can kind of like speed up our development time, unlike kind of like last time where we kind of had to wait a little bit and see if there was something wrong in the back end. Now we can kind of like move forward and do some quick tests like this, or doing the Mocha test like I showed a little bit earlier. So next I'll pass in some multiple arguments. I don't think this will handle it as well just based on the arguments that we're passing in, but we can show this just for no. So now we have a handle request was 1, and then it says malformed request as well because we're not giving them a profile ID that is valid for this to execute appropriately. I believe I need to check 1. So like if we go to the code, let's check like what arguments that we're passing in. So whenever it's saying handle request, this is where we're seeing this here. You see this log print here, handle rec, in this case, like handle request. And this is supposed to be a hex string. So what we should be passing in is like a 0x01 in this case, right? So we have a hex string here for the handle request, the request ID, encoded profile. So what we really want here is to be able to take this request ID, encoded ID, and be able to decode from our request hex string the value here. So I'm not exactly sure how the format should look like. I need to run that through the, maybe it's in the test. Data, that would be it right here. So like in the case for just for time's sakes, this would be like the fat function. So you see how it's like fat-fn. That would be if you were to install it on your machine, but at Phala/fn is the same thing here. And then being able to query the endpoint, which was the settings that we saw earlier, and then the data, which would be the request ID pointing to the mapping of the profile ID in this case. And then what I showed earlier was the starting of the local hard hat node, and then running that test on the local host in this case. And then these other ones here, if you want to extend on this a little bit more, you can also deploy your consumer contract. And what we also added was this localhost watch. So we added some additional functions below here. Where is it at? In the fat rollup anchor. After a queue remove item, we added get tail index, get head index, get storage key, tail key, and get current, so that we can allow developers to debug locally with the watch command in this case. So for this like yarn local watch, I can test this out right now. I did it on my other contract that I had, but I hadn't tested this just recently.
And just to recap, the entire testing suite is just to avoid people from having to relaunch their API node with the FA tokens, right? Like they can just do this to make sure it's all working as correctly. But if they were in a pinch and they really needed to do it, they could always just stake the FA tokens and create the API and just find out the costly way.
Yeah, exactly. And also I think it's also pretty good for those that that may not have participated yet, but they want to just test locally before doing any kind of deployment, just to see what is expected. And then, like you said, like they don't have to sacrifice any tokens, even testnet tokens, I guess in this case too. But yeah, this is kind of like based off the feedback we got and how we wanted to like create like a better development experience in this case when it comes to like locally testing before we launch the new UI with the fat functions in this case.
Yeah. So, and it's already set to go. So all I have to do is fork the repo and the test will just work automatically with a good example on there. So they can just, get to testing right off the top, right? And this for the Lens API.
Yep. Yeah, exactly. So they'll be able to run the test. They'll be able to deploy their consumer contract locally and then be able to run the test against what an expected function would look like. And since and these functions are also calling the libraries that we have available to our fat functions in our backend in this case. So So you're getting like a true result of like what you should expect. Just in this case, you wouldn't have like the privacy preserving and security guarantees of the secure enclave of your programs running within the P runtime. Are there any other questions in the chat so far?
Nothing yet. I think we're good. We can get into the NFT part.
Cool. All right. So move to the NFT part. This is the repo here. Let me go back to here. So I put the Intense sports ball repo, which is going to be the consumer contract repo here. I'm finishing up some of the documentation in the README, but I kind of give a background. It's not a true traditional sports book. I kind of just created a story based off of a video I saw from a long time ago on YouTube. If you want to look at that, it's called I think it's called like Sporty by Kyle. But anyways, pretty much I just created a scenario where he's lost all his money and he decides that he doesn't want to participate in sports books anymore. He wants to create his own, and he had found out about what intents are, which an intent is a signed set of declarative constraints which allow a user to outsource transaction creation to a third party without relinquishing full control to the transacting party. So what Sporty pretty much thought was he could flip that and make it for his sports book only fulfill his intent. So all the funds just go to him so he can pay back his debts. The goal, though, what I wanted to show here was the different functionalities that you could include by using Phala Network's FAT functions here. By one having like a nestable NFTs for the basic functionality of like a user profile NFT nested with NFTs of user bets. The example I'll show will be more geared towards the odds API, where I generate the 3 sports and then I nest NFTs into the sports collection. So there will be like a baseball, football, basketball, and then I'll nest mint teams underneath each of those NFTs. So I don't know if anybody's looked at what the nestable NFT standard for Remark has proposed with proposed with the EIP 6059, and there's other ones as well. But this link here can kind of take you into like the realm of like nested NFTs and equipable NFTs and all sorts of like very unique things that you could build with FAT functions in this case. Like so there's like a lot of really creative things that you can do here with the Remark standard. Also, I'll show like updating Telegram group of the latest info about sports game scores, query multiple API endpoints. So in this case, I just use the odds API, connect to off-chain storage. I used a key value database to update, and then connecting to the EVM chain through the consumer contract, which kind of showed already with the last workshop that we did. But just to get started, I'll show you like the first parts of creating like the Remark NFTs. So I also put here a separate repo just to kind of separate like the Remark NFTs from the DApp that I built for the Intense Sports Ball. But this repo here in the gist will have the contracts and just some simple instructions on how to deploy. But I'll have the contracts here where they're very simple actually. So in this case, this is the sport smart contract, which is the parent, which is going to be the parent NFT of the teams that are within a sports collection. So we have like our traditional mint methods, add asset entry. So I also use the remark nestable multi-asset standard. So the multi-asset allows you to add different types of metadata. So like say that you have an NFT that is has like a audio file and a like an image file and a video file, and you want to add all these assets to that NFT. Well, you can do that through the add asset entry, and then add asset to token to take the tokens and the asset ID token IDs, and then add these assets to those token IDs in this case. So this is just a very basic example, but you can extend from this. And there's also documentation from Remark about this as well. But that's kind of like the basic case. And then I created a script under user journey. And in this script, I will, in this case, I don't use the user here, but I have the owner of both the collections, which is Sporty in this case. We create the sport smart contract here. We have the team contract here. So we have 3 sports. We give it a symbol and then the number that we're minting. So in this case, I'm just minting 3. So now I have like the sport deployed, and then we have the team, create the teams, the team collections deployed. So now we have like we'll have like a log print here that will show these addresses for the deployed smart contracts for sport and team. So now I want to mint the sport NFTs. So I just call mint owner.address 3. So the 3 NFTs that we want to mint. I created a few asset entries. So this one is just like the overall collection asset that all of the NFTs will get. So the 3 NFTs that are minted in this case. So this would be like a sporty profile picture, which is just like a jacket that says sports on it. This one's like a AI generated intense sports baseball image, and then football, and then basketball. And then from here, I then add the assets to the sport NFTs. So all the NFTs are going to get that first asset here. So I add asset to tokens 1 to the 3 minted NFTs, and then I correlate each one. So the first one will be the baseball one, so that will get the baseball asset. The second one will get the football asset, and then the third one will get the basketball asset. Are there any questions so far about this? Does it make sense so far?
Just to reiterate, like let's say we're creating a category, right? We have the baseball NFT, and then in the baseball NFT, we are then saying, okay, let's build a team, I guess, under the category of baseball. So to say, like, I mint out a Dodgers and a Yankees NFT, right? So then I can theoretically send them to the baseball NFT, and then it's all under that single baseball NFT, right? It's kind of like it's holding all the teams.
Exactly. So down here, what I show is this is like kind of like that power of the nested minting. So you can actually like directly mint it to the sports address and the NFT ID. So in this case, like you were saying, like the baseball NFT, you can just call team.nestmint. You define the sport NFT contract address here, the NFT ID, and then how many you want to mint. So like in this case, the first one was baseball. So there's 30 MLB baseball teams. So I mint 30 of these. And then for football and basketball, there's 32. Football, the American football, sorry. But that here. And then from there, I didn't go ahead and like do all the get every single team image and then add them as an asset. I just kind of was working off an example just because of time. But essentially, here, whenever you do mint a child NFT into a parent, the parent owner of that NFT has to accept that child NFT, because that if you don't if you just allow all the NFTs just to be kept being sent, there could be some kind of like spam problem in that case. So the owner of the parent NFT that has the child sent to it, or the nested grandchild, whichever, has to accept the child in this case. So it does an accept of the child, 1, 0, team address, and then 1. So in here you say token ID, index, child contract, child token ID in this case.
Very cool. So you could almost make like a fantasy football league with NFTs, and you can draft your guys, and yeah, super cool.
Yeah, that's like that was kind of like what I was gonna try to do at first, but then I was like, wait, that's just like so ambitious, and then I just like I had to make it as simple, but like get people kind of like interested, because the Remark NFT standard is really cool, because I've worked with it before, and like with Phala World, we did the substrate Remark, like core version of it. But now that it's like available for EVM developers, and there's like the EIP proposals got accepted, and now there's a ERC token or contracts for this. It's really nice to see, like, try to get some developers to build on it, because there's a lot of cool things you can do with it.
Stoic Dev has a good one. You can also implement an allow list to do collections to get auto accepted. So that's a pretty cool idea as well.
Interesting.
Yeah, so many cool ideas that come out from just this project alone. It's like brains churning.
Yeah, that's why I'm like trying to show as much as I can, because it's like it's great to show like a use case, but it's like, oh wait, well, what about this and this and this, and just like kind of give examples so that people can kind of explore their like creativity in this case. But yeah, these are the to get moving forward. This is like how, like, an example of how you would do the nested NFTs, and then we can move to the intense sports ball DApp. So in this case, I did show earlier my current progress on this, which it's taking like a lot of inspiration from the Lens API treasure hunt that I built, and as I extend it over the next 24 hours before the hackathon, so I can give y'all more examples, I'll update that here. But essentially, what I was thinking was, since the premise of this is Sporty is trying to earn back all the money he lost through all the other sports books that he betted on and lost all his money. He essentially needs to create some kind of sports book that looks legitimate, that's querying in a sports book API of multiple sports books, and being able to offer these different bets. But essentially, he will have people bet, make sure that they bet the minimum bet cost, and then they'll put a game ID. The game IDs will be taken from I guess like taken from the odds API. So I'll show you like an example of the content. So in this case, you can see this would be like an example of like the HTTP request of getting all the scores. And you can also define the time, the way that the time is listed in here, like whether you want ISO or where is it at? Yeah, ISO or Unix timestamps for this. But essentially, that that this update sportsbook function. What I'm doing with this is I'm going to create my fat function in this file to be able to check the arguments that's being passed in and check for this word update here. Whenever it says update, and since it's only going to be called by the owner, it will then go to my fat function, and then my fat function will have some logic to handle it to then call this the odds API to retrieve all the games that are coming up for the current day. And what I will do is store the game ID, the home team, the away team, and then I guess probably the sports title, maybe the commence time, but I'd probably use the Unix timestamp. And then from there, I'd take that information, put it into a text string, and then send it to the Telegram group through the bot. And this would be happening with the batch HTTP request that I showed earlier. So in this case, what I would want to do is have a Telegram group of users that want to execute bets. They would see all these game IDs and all these different games that are going on. They could then submit like a question about a request for the odds of a certain game, and then I would return the odds from this function. Oops. Yeah, sport odds. Yeah, so I take the sport odds and then I define the event ID. So the event ID is the game ID in this case. And then from there, I would see all the different available sports books, right? So they have like bookmakers, DraftKings. So they have a key DraftKings. It's a head-to-head matchup. And then you have your price here, the last update in the Unix timestamp. And then I would report that back as the options that they could choose. And then they can then enact another function call request to execute the bet. So like here is where I would have the bet. It would have the game ID. It would take the minimum bet cost and do all the calculations on the fat function side to be able to then give Sporty his take, because he's pretty much just taking all the value of all the bets and not adhering to anybody else's intent to make any kind of money. And then having like a on message receive, where like similar to the last one, I would then take the receive, which would then give me the locked in odds that they bet on. And I haven't implemented this part yet, but I will a little bit later. But I'll connect it to a bets NFT and lock in the odds with the metadata that they need, that they have for that specific bet, in case that the odds change in the API. So they're locked in at the odds that they're betting
right.
in. Yeah.
Like a Uniswap v3 position, right? Like that, it's going to lock your position liquidity, right? So like it's kind of like similar to that. Exactly. Where it just locks at the odds at the time you did it, and if the odds change, somebody hurt their hand before the big game, and the odds change drastically, but that's what you locked in at. Right?
Mm-hmm. Exactly. Yeah. But yeah, that's like the high level of the where is it at? That's the high level of these three goals that I wanted to show. So the next part is just kind of showing the code pieces, because just like what I showed earlier, you'll have you can generate your template. You'll have a similar template to this, and then, well, you'll have a similar template actually to the Lens API Oracle consumer contract. And then from there, you can then have like a full customization. So in this case, you can change the name of this contract. You can then go into the index file. If you don't want to interact with Lens API, we're creating some examples that you can use as well to different types of API connections, so that you can query, post. I think there's fetch or not fetch. Forget which ones that we support right now, but for the methods, but the prime ones are get and post. And from there, you can kind of get real creative with whatever you're going to build for the hackathon. And I'll be around a lot for this hackathon, because there's going to be a lot of room for people to run into different types of problems. But the positive thing is you can run into these problems locally first, and then move to deploying to testnet and mainnet to kind of get moving faster. But what I will do after this workshop will be creating these videos whenever we have the implementation done to show you the process of deploying from your command line to the testnet and then to mainnet as well, and then being able to view your deployed fat functions in the Bricks UI after, in this case.
So for those that were doing the hackathon previously, that did the Lens hackathon, the only major difference is the entry point, right? It's just the fat functions that have changed, and then everything else is similar, right? Like, it's just basically you're going to do your call, then you're going to call your contract's going to get received, and then it's going to do whatever it needs to do the contract. We just added the ability on this workshop for the nested NFT with the new ERC. So it's some fancy flair, but pretty much it doesn't change other than working on the fat functions directly.
Mm-hmm. Yeah, the only thing that changes is really just you get access to more APIs, and you can kind of define what you want your application to do.
Yeah, definitely. And so those that are curious, we have certain criteria for actually getting FA tokens, right? So if you submitted on the first hackathon, you had the time to do it and you were able to submit, that puts you on the allow list for the FA token airdrop. We already have your wallet addresses from the submission forms to get that. And now there's going to be another submission form for this upcoming hackathon, if you haven't signed up already, to put your idea and your wallet on there, and that will go under review for under Phala to see what you get the tokens with. DevDAO members do get kind of, I think it's, correct me if I'm wrong, it's kind of automatically approved, I believe, if you're a DevDAO member.
I think so. Yeah.
And then if you happen to not be a DevDAO member and you still want to do it, you still can. It's open to everybody. You just have to do it on testnet first. Give the idea, reach out to Joshua, tell him your idea that's on testnet, and then in order to get it on mainnet, he's going to airdrop you the token so you can deploy this on mainnet. In order to win the submissions, it's $13,000 worth of FA tokens and co tokens. You have to submit to mainnet. So that's one of the conditions in order to do that. So obviously they set up a nice local testing system, so we're not blowing money and blowing gas every time. And then we can actually, once you feel good, deploy to mainnet for your submissions. There's also going to be 2 other types of contests as well. And it's going to be a technical blog. Technical blog should be able to describe what Phala is and also how to deploy onto mainnet as well. So you do have to get a little bit technical. And then we're also going to have video content, right? So there's going to be like a video structure, like what is Phala, how does it work, and spicy details. Twist to that one is Phala is hiring, right? You guys are looking for a dev relations engineer and a media content, right? So no better demo reel than your submission on your video content, right? So, just keep that in mind. So it's definitely open to everybody. Like, you don't have to be a DevDAO member. You didn't have to submit in order to submit in this one. This is a brand new hackathon. We're just making the allow list a lot easier because you've shown that you've been able to distribute, because there's real money involved. So, you submitted before, you're definitely in. DevDAO member, write up your idea, you're most likely in. And then if you're brand new outside, just, build out your idea a little bit, show Joshua, and you're in, for the submissions, you'll get those tokens. I'm going to throw out any last minute questions that we may have, but we have that gist, and it looks pretty solid. It looks like it has a whole lot of stuff in there. I'm really digging the 6059, so I might play with that a little bit more. You caught my attention with that one. Yeah.
Oh yeah. I can definitely. I'll send over. I'll add to the gist all the remark docs as well. And make sure that people know which version to use too.
Yeah, yeah, definitely. I mean, it's kind of like limitless to whatever your API calls are. So, oh yeah, thank you. The RSVP form right there. It's just been set right there. The fat functions hack. Make sure to sign up. You know, if you miss that time frame of the sign up with your idea, there's still a chance, but your chances get slimmer and slimmer for that airdrop. So definitely make sure to just, you know, fill out the form right now if you're kind of hesitant or not. Sign up now, throw out your idea of what you may be, you know, thinking of building, and the Phala team will definitely reach out and we'll coordinate as needed. So a lot of cool stuff you can do, a lot of cool stuff to learn. I mean, this may look like we're going to need some partners on there because it's pretty hefty to get these fat functions working. The hackathon is starting in about 24 hours. So it is starting tomorrow, and that's going to go all the way to, I have it in front of my head, but I don't have it. I'm looking at the page, but through Sunday, I believe, right?
I think I know. I think it's the 11th, right? I don't.
Yeah, the 11th. I was like, I'm looking it up right now on my calendar. Monday.
Monday.
Yeah, my bad. I'm trying to. So basically, tomorrow through Monday. So you know, obviously the testing is going to be a little confusing. Calling multiple APIs are going to be a little confusing. Joshua is going to be on, you know, office hours every day. Every day. Thank you, Kim. Every day of you know, of the week while we're doing the hackathon. Available for questions. Definitely get your testing questions up front. I know that was always something that people were waiting last minute for. So definitely get those bugs out while Josh is around. We're also going to have 2 DevDAO members having office hours on Friday. We're going to have Phil helping with front end issues. So if you have questions about front end, DevDAO has your back. We're also going to have Solidity with crypto. I think that's going to be like at 9 a.m. PST and 11 a.m. PST. In between DD Fridays. So like if you miss Joshua's chance, but that's more specific for Phala. If you're just having a problem with your Solidity contract or your front end, definitely reach out to the DevDAO members that will be available to you. We got your back. Right. So I mean, it's exciting. It's kind of cool. It's like what we can do with this. I don't any final words on that one, Josh?
Not just yeah, I'm excited to, you know, help out and see what y'all build, and then also kind of try to build alongside y'all so I can come up with more examples for y'all to build on.
Yeah, very cool. So just to reiterate, it's $13,000 in FA tokens and code tokens, which is super awesome. We got quite a few prizes. It's like the fattest, you know, so I don't think there's not necessarily a first, second, third, but different categories that you can win from. So there's a lot of opportunities to win. You didn't have to do the hackathon, right? You can sign up now, get yourself on the list. All deployments to qualify for the prizes have to be done on mainnet. And so they're going to supply the gas for you depending on where you are in that category. And the hackathon starts Wednesday, ends Monday. So you got all weekend to weekend hack if you're a weekend warrior like myself, and get to going. Cool. Thank you so much, Aja. This was pretty cool. I'm going to go ahead and minimize this part, but that was cool. Like it was like such an in-depth one. You had the gist. I'm going to throw that gist one more time just in case anybody missed it. And definitely go through the docs, mess around with it tonight, get yourself familiar, and then we're off to the races for the second Phala Hackathon, and there we go. All right, guys. Then if there's no more questions, we're signing off. Have a good one, guys.
See y'all. Thank you.